Hi, so I'm Evan Triplicki, and depending on where you're from, you might say it different. So I designed this programming language called Elm that's focused on front-end programming, so doing stuff in the browser, interactive applications, games, this kind of thing. And so I'm sort of coming from a perspective of typed functional programming. And one thing I think about a lot is this question, like, if typed functional programming is so great, how come nobody uses it? And I think this is a question that people sort of outside this community ask, and I think it's a reasonable question for them, just like as a filter, right? Like, obscure things aren't always amazing. It's something that I don't think we ask within that community enough, right? Why is it that we don't have more users, if it is true that we really are doing something really great? So the rough theory is that we're engaged in a decent amount of self-destructive behavior. So I kind of want to talk about sort of how Elm sort of, how I think about these things and how Elm tries to do a better job dealing with those things. And I don't want to be like a mean guy. So I tried to frame things in a positive way and not like be too mean or anything. Like, this is all meant as a how can we do better kind of thing. So for me, I think it's valuable to sort of think about like the history of programming in trying to figure out what's going to come next. So this one's actually the history of programming as seen from JavaScript. So if you try to do I tried to do a more realistic history. It just broke down. So what does history look like from like JavaScript world? So in the beginning there was assembly, and it was hard, but somehow people wrote Super Mario in it. So that was pretty cool. But we got to this crisis point where things just like weren't working out anymore. So like along came C, and now we have the structured programming approach. And like, okay, that's not exactly how history went. Okay, but this is as seen from JavaScript. So C comes along, and suddenly we're not doing this really low level thing. We're doing like a much higher level thing. And that's true for many, many years. And at a certain point, we get to this other crisis point where it's like, and Java comes along, and we're like, oh, great, this is amazing. Eventually we get into JavaScript. And these are sort of roughly arranged time-wise. Like, it doesn't exactly line up time-wise, but from the perspective of JavaScript, you sort of say like, well, before us there was Java, and before them there was C. And it's kind of a true enough. In fact, it's true from that perspective, so it might as well be true. So when we look back, the C and Java and JavaScript programmers can all look at assembly and be like, oh, it was a maintainability nightmare. I couldn't write this in a portable way. I couldn't have people read this easily. So we solved that when we went to C. And now the Java and JavaScript programs look back at C and they're like, memory management. How could they even deal with that in that crazy language back in the day? And so that sort of was the ingredients of this crisis point that at least perceived how we got to Java. And when JavaScript looks at Java, they're like, how did people deal with all those freaking types? Like, how can you get anything done at all? And so I have a feeling that we're at another one of these crisis points where the issue again is maintainability. So when you talk to companies that have, let's say, 50,000 or 100,000 lines of JavaScript, they're in this place where when they add a new feature, they're going to break 3. So one way I think of it is like Facebook used to say like, move fast and break things. And I think it's sort of shifted to like move slow and break things. So what I'm getting at though is like at a large enough scale, people are starting to see issues in practice. And that's not to say that this isn't a valuable place to be, but we're starting to get these like rough spots. So the question you might ask then is like, well, okay, so what's this next era gonna be? What's the next part of this history? And so maybe that's something functional. Maybe it's way crazier than we imagine, and it's a stack-based language or a Prolog, right? Like, something insane happens. Maybe types will be involved, maybe not. So like a Lisp or a ML, maybe it'll be something gradually typed. These are all viable in different degrees, right? I add this Prolog and Stackbase because, these are small communities that people really love a lot, and maybe they're great, right? Like they say they're great. Should I believe them? I don't know. So for me, I think of, well, a typed functional language is going to address a lot of these issues. We can look back at history and say, we got the memory management under control. We got all those freaking types under control in the sense that if you can infer all that information, you can get a lot of the benefits without the like really heavy syntax that a lot of JavaScript programmers look at and they're like, ah. So, and then maintainability as well. So the problem with that is that in 1973, like ML was introduced. Okay, so this is 1 year after C. C was 1972. But for some reason that didn't work out. Something mysterious happened. So we had another chance, 1990, Standard ML came out. So this is actually 5 years before Java. Java's 1995. So we could have gone that route, but for some reason it didn't happen. And in 1996, we had OCaml. This is 1 year after Java. It has objects, like it's got it all. Like what's the problem? So in all of these situations, we're sort of addressing the core concerns, but in a way that for some reason didn't connect and didn't make it big. So when we think about what's going to happen next, I think it makes sense to ask, who's going to be deciding what happens next? So we've got this massive chunk of front-end programmers, people who day-to-day are making web applications, making games. And we've got this tiny population of people using typed functional languages. Now, this isn't to scale, okay? I don't know how small that red dot should be, but. So to try to put in perspective, Oracle says that there are 10 million Java programmers. And if I try to do some estimation, I can say, okay, so maybe there are like 200,000 Scala programmers, maybe more, maybe less. And then how many Haskell programmers are there? So like we're talking about orders of magnitude difference here. Like the number of jQuery users is like way huger than the number of people who are doing these functional languages. I think, I don't know. So if this giant group of front-end programmers are going to be deciding, we should understand what they want in this next era of programming. So I think there are two sort of main axes that we can think about that are helpful here. So we have JavaScript, and the axes here are usable. And what I mean by usable is the ability to use it. So I sort of define that as like the time it takes to get from a novice level to actually a product that you can show your friends and be like, hey, check this out. So I wanted to demo something real quick. So this is Google. Guys, I'm using JavaScript. Like the time from novice to getting something done was like, it's unreal, it's crazy. I don't think anything has really matched that. And like, if this was a competitive market, this would probably be like abuse of market position, that it's baked in this way. But like, it's really, really easy to get started here. And so if you're doing some kind of, let's say you want to get a web page up, maybe that's a 5-minute or an hour-long process, even for someone who's a total beginner. So that's a really amazing ability to use the language. Now, the issue people are having is about maintainability. Now I've got 50,000 lines. The company I made is successful, and we're getting new users. We're trying to add new features, but we're having trouble doing that. So another point on this map is Java, right? So we have much more maintainability here, but the usability is down. And so this is more about like the time it would take to start using Java is just longer. Rather than 5 minutes or an hour, you're looking at something a little bit more. And that part of that's learning time, part of that's getting things installed, getting things set up. So from the JavaScript programmer's perspective, like this is a no-go. I mean, partly from the maintainability and usability, but also partly from an emotional sort of crazy standpoint, where it's just like, ugh, like that's kind of the logic of this isn't viable. So what we want is to get that maintainability and either keep the usability or even improve it a bit. And the direction people are taking here is gradual type. So you're seeing this coming out of Microsoft and Google. Like a lot of companies are betting in this direction. So you can keep the usability profile where when you start out, it's very simple, and as your thing grows, you can add types to it. What I don't know if people are thinking about is like, what is the end game here? When we have a JavaScript program that is fully typed, like, didn't we make Java again? I don't know, maybe not, but there's something here where I don't know if that's quite an exciting resolution. I don't know if that's what will satisfy people, but it is addressing the main concern. We get this maintainability. Now, what a lot of JavaScript people don't realize is that this graph is actually way bigger. You can be much less usable than anyone imagined. What's interesting, though, is you can actually be way more maintainable than a lot of people think about as well. So in the top right corner, or top left corner, we have the ML family of language. This is like Haskell and OCaml. So I can speak to my experience getting started with Haskell that led me to put it in this corner. I'd say it was a good year before I was like, I'm pretty good at this. And it's just not that way in other languages. So when your setup takes a couple days and the learning process takes months or years potentially to get to an expert level, it's making things really hard for people. So the important point here, though, is that the levels of maintainability that are available are way higher than people think about. So what I want to do is I want to get to this magic realm where we get that level of maintainability, but we have something usable. We have something that in an hour or in 5 minutes, people can get started with and be productive. So the question is, how do we get from here to there? Okay, this is a trick. This isn't actually the thing we want to focus on. It doesn't make sense to try to move these languages to this nice place, because that means we're moving a really small set of users to a place that they generally don't necessarily want to go. In the sense that if you make a really nice front-end programming language for people who don't do front-end programming, I don't know. So the thing you want to do is actually get JavaScript to this nice place. So when you focus on what a JavaScript programmer needs to get there, you end up making different design decisions. So this is kind of the shape of the world from sort of as I see it. So the next thing to think about is, what does this mean for designing Elm? So the broad category I named this is like user-focused design in Elm. So I know that I am designing for people who are doing front-end work, and they have specific issues that they need addressed. And if we're able to address them the best, then we'll win. If we aren't the best, maybe some random things will happen, but if we can do better, then we have a better chance. So the sort of key design principles here are, first, gradual learning. When you have a bunch of stuff to get used to, it's good to have a really nice learning curve. So in JavaScript, you have this. You can start doing stuff really quickly. In Python, you have this. In a lot of functional languages, you don't. On day one, you get smacked with a lot of details, a lot of intense-sounding stuff. And is it possible to make progress and be productive without learning all that on the first day? So the second one is communication. So maybe we have something good, but are we able to tell people that in a convincing way? I think right now we don't do well with that. That one I have a lot to say about. Finally, we have culture. So what does the community focus on? What do they find important? So you'll notice so far I haven't talked about anything strictly technical. This is all sort of community, cultural. It touches on documentation. But it's going to impact the technical decisions I make. And I think this is also stuff that can be designed. This is something that you can think about and do a better or worse job at. So the last one of the last points is usage-driven design. So based on these sort of foundational things, what does it mean to add a feature? And finally, we have tooling. So how can we do a really good job of making great tools? So, okay, let's get into this. So gradual learning. So this is something where I think it needs to be designed into the language and libraries to really work. So you can design the language such that as someone gets started and gets productive, slowly they realize these concepts in a way that builds upon each other in a way that works for people. So a nice example of this in Elm that came out recently is called StartApp. So, okay, so this is a little StartApp program. I have start, and I give it a model, a way to view that model, and a way to update that model. So this is just a counter that I can increment and decrement. And the initial model is 0. I view it, so I'm generating some HTML here, a div, it's got a button. I say what the number is, and then another button. And I have a way to update it. So I increment it sometimes, and I decrement it sometimes. So someone can get started programming without really doing any functional programming. Like, this isn't that far off from something like CoffeeScript. You can actually get something going in very little time without getting hit with a ton of crazy concepts. So I visited the WWDC conference and met a guy who did a lot of Swift programming. So he opened up this program and just added a reset button, and like in the first couple minutes, like 2 minutes in, and he like didn't really know what was going on, but like he was able to add a feature, and that's amazing, right? He didn't have to read a tutorial, he didn't have to read a paper, he just like looked at the pattern, added a thing in, and added the feature he needed. So that's a great kind of learning curve. He's able to start doing and have the confidence to do stuff, and slowly fill in the gaps. And I think this focus on gradual learning is a big part of why we're starting to see some education uses of Elm. So there's a class at UChicago that was taught in Elm, and they did a mix of doing front-end stuff and doing some data structure stuff. But there's also one called McMaster Outreach. So this is a program for 4th through 8th graders. So this is a little, this is a session they did. So these are some kids who are writing in Elm's online editor, and they made Spider-Man. Someone has a question. I'm sure he got it, though, eventually. And they also have a Hall of Fame of stuff that people made. So this is made by a 6th grader. This one's crazy. A 4th grader made this. Like, how did he even watch the movie? So you start to see, like, this is something that you can get up to speed with in a really nice way. So the next topic is communication. So this is something where I think we can do a lot better. So I want to do a little thought experiment. Okay, you're going to hear 6 pitches trying to solve the same problem. And essentially, you're a busy person. You know, maybe you just, you're a team lead. You just had your first kid. Things are going crazy. The project you're working on is it's more people than you've managed before. And you're looking around for the right way to deal with that. So you hear, there's this JavaScript library for building user interfaces. Well, I use JavaScript. I need to build user interfaces. That sounds pretty good. You can write JavaScript the way you really want to. That's actually exactly how I want to write JavaScript. That sounds really good. You can have a framework for creating ambitious web applications. I really love this one because it like guilts you into it. It's like, do you want to write an unambitious one? I think that one's really well done. Maybe you want HTML enhanced for web apps! Exclamation point. It's weaker. I don't know if I'd look into that one. But maybe you want scalable, productive app development. Sounds kind of Java-y, but yeah, I could be into it. I could check that out. Or maybe you want an advanced, purely functional. Yeah, advanced, purely functional programming language. It's like, well, do I want something advanced? Do I want something purely functional? I have a lot of code that's not that. Is a programming language necessarily the solution to this thing? So you're really not connecting with people who are looking at this thing at a fairly early stage. So people who are just glancing through, they don't have time to spend 6 months learning about the different characteristics here and why it's a good idea. Like they're just going to look at this and say, like, I want to build user interfaces. That we lost, you know. That we missed the person moved on. Essentially the question is like, how likely are you to explore the one that doesn't directly address your problem? Like, how often do you hear a pitch that doesn't make any sense to you, and then when you look into it, it actually works, right? The general advice I have is be direct. Like, you want to say exactly what you're gonna provide. So another way to say this is like, leave nothing to the imagination. You don't want someone making 4 mental jumps before they understand what you're saying. You want it to be an immediate comprehension. So I have a couple examples here, and I'm going to try to not keep it chill. So one word that we use a lot is pure function. So the way I'm going to do this is sort of deconstruct the word from a JavaScript perspective and then provide an alternative that I think is better. So pure function, I don't know what that is. It implies that they're impure functions. Neither of these things are things that I have in my worldview as a JavaScript programmer. So at that point, some people will just move on and say that doesn't seem interesting. Some people will go to Wikipedia and look up what a pure function is, and they'll say, okay, I guess that kind of makes sense. Now at that point, some people will say, I don't know if that's really relevant to me, and move on. Some smaller fraction of people will say, okay, that might be interesting, and then they'll look into more. But so we took so many jumps to get to someone potentially being interesting that we're losing a lot of people. I have had a lot more success saying stateless function. JavaScript programmers have state. They know that it often causes issue. What if you didn't have that state in a lot of your functions? So it directly connects to something that happens day to day in your code and says, hey, what if you didn't have the problems that come from that? I don't know if that's the perfect term, but it's certainly an improved term, one that connects to how people use stuff. Another phrase that people say a lot is easy to reason about. So my mom, she likes to review my work. So she actually read my thesis before it was time to turn it in. And she came across this phrase and she was like, I don't think this is English. Like, I think you forgot some number of words. Easy to reason about. Like, it's not really clear what that's going to give me, right? Like, was it hard to reason about? Like, I'm a JavaScript programmer. I spend a lot of time reasoning about what my code does because, like, weird stuff can happen. So another way to say this is it's easy to refactor. So just connect it directly to what's happening in your code. Do you have problems refactoring? Well, what if it was easier? And you can kind of take the inference steps and say the last one. Another one is safe. People like to talk about safety. But safety is kind of boring, right? Like, a safe investment is like bonds. No one's really like, oh, bonds, yeah. Yeah, you should see my bond portfolio. It's been like 2% growth. It's amazing. The image of like floaties, you know, like that's what I think of when I think of safe. And to connect it more to code, like when I write JavaScript code, I don't think about it as safe or unsafe. It's not like it's going to punch me. You know, it doesn't really connect with how I think about the code. So we've been saying reliable in the sense that you get runtime errors in JavaScript. So what if you had a program that didn't do that? What if you had the reliability that you want? So last one is monad. So this is a term that I struggled with a lot. I don't know how many people go and say that, but I would say it was a good 6 months to a year before I felt I really was on board. I won't say on board. Before I really understood what was going on there. And I think I didn't have a deep understanding for maybe a year or two more after that. And when I finally did understand, I was pretty upset that it wasn't actually a complex thing. So there's something about this term that it asks you to think that it's complicated, right? So my experience learning it was like, oh, I want to print something out. Okay, I'll use a monad. Well, that needs category theory. So should I buy a book on category theory? And like, I'm not learning from a professor or from someone who's used Haskell a lot. Like, I'm just sort of going through like, what would make sense? Here's a term that I don't know. Well, then I should learn what it is. Oh, it's dependent on this. I should learn about that. And yeah, a Haskell person would say, oh, you don't need to buy a book on category theory. But Haskell is saying you should, right? Like, I need to know about monads. So there's a story I like to tell that sort of reveals this in a way that doesn't actually connect to people's preconceived notions. So let's say there's a person who, they have an apple in each hand. They say, I have an apple and I have an apple. How many apples do I have total? And so you say to them, well, first you need to understand group theory. So there are 4 laws: commutativity, associativity, identity, idempotency. And so you can do all these commutative operations. If you follow the laws, it's really cool. And they see that the person is like, oh, I have an apple here and I have an apple there. How many apples do I have? So, okay. Let's be more concrete. So multiplication on integers is a group. Rotation in 3D space around an axis is a group. Do you get it? So when you put it in that framing, it sort of reveals that it's a crazy way to teach addition. Like, there's a reason we don't take that route, and maybe that route works for some percentage of people who are learning, but I'd say for a vast majority, let's say 95% of people, saying 2 is a better explanation, right? So the point I'm making here isn't that this is an unimportant concept, but it's one that we emphasize very, very early, very, very emphatically, and sometimes in a way that's actually confusing. So another aspect of this is often people say like the state monad, the IO monad. It's a very weird thing because it makes the noun monad, like it's a physical thing. It's like saying, oh, you want to add numbers, just use the addition group. Like, why would you say that? Just add them. So there are a lot of ways we can deal with this. The general thrust of it is you can essentially be very active using monadic things without ever talking about it. So in JavaScript, for example, the promises library has a function called then. So I can say, here's the thing I want to do, and when it's done, then do this thing, then do this other thing. So we found it's actually really effective to say callbacks. I suspect people will be mad about this, but so if we look at, we have this and then function in a bunch of different libraries. So in maybe, for example, I can say, here it is. Try to turn it to an integer, and then turn it into a valid month. Okay? You can read it the first time through. It's not crazy. Do this and then do that. And we don't have to talk about any concept here. We just say, give us a maybe and give us a callback. If you're successful, we'll keep going. If you're unsuccessful, we'll fail. So you're able to get the core concept in a way that doesn't introduce any extra stuff. And so as people start seeing this in different libraries, maybe they'll be interested in the general pattern. But the point is, you don't have to understand the general pattern to get up to speed and use this kind of thing.
When somebody you want to tell something, there's a general pattern here. What do you call it? It's a little bit like you say.
You call it a monad, of course. Obviously. The point is, you don't have to do that on the first day, right? Like when you want to know the general pattern of addition and multiplication and rotation in 3D space around the axis, you call it a group. That's what it is. But the point is, you don't have to talk about that on the, super early on. Okay, so then I have one last note on communication, which is about obvious names. I really like obvious names. I was at Microsoft briefly, and everything had a 3-letter abbreviation. So there was a joke that like everything was a TLA, a 3-letter abbreviation. So they'd abbreviated the So in Elm, we try to just like be very literal. So the tool for building things is Elm make. The tool for packaging things is Elm package. The tool for Elm HTML the tool for HTML is Elm HTML. Like, can anyone guess what Elm Markdown does? Like, it helps you do Markdown. So just like making it so there's no extra steps that you have to take is a really important goal for me. Okay, next is culture. So this one I think was a cool realization that I was running a meetup in San Francisco, and the setup was someone would do a talk, a couple people would show up, maybe like 20, 25 people would show up, and generally it was a pretty like elite group of people. So people who had PhDs about some sort of functional programming topic. So essentially, when you do like, there's a person talking and a bunch of people listening, you get like a group of people who are relatively elite, and you try to make them more elite. So I met this person who was running a meetup called Dames Making Games, and the way it was set up was as a hackathon. People show up, they pair program together, they work on a concrete project. So they say, today's focus is a side-scrolling game, and let's focus on that. And so I started trying that out for the Elm meetup in San Francisco, and the makeup of the attendees changed dramatically, right? So it was people who were totally new to Elm, it was people who were interested in using it at work, people who were making packages to do front-end work. So just by sort of changing the focus of the meetup, you change the makeup of the community, right? So essentially, by doing that, I'm sending a message to people who are interested in using Elm, in that Elm is interested in being used as well. So I think that was actually a really interesting technique. So another example of this culture of like just getting out there and making stuff is there's a company called NoRed Inc. in San Francisco, and they recently started using Elm in production. And essentially the way they got it started was an engineer decided like, I'm going to do this, and he did it. Like a lot of times you get blocked on smaller issues, but it's important to sort of see like, if you decide to do it, it's not that difficult. So another one is the time traveling debugger. A lot of people think I made this, which I didn't. So if you haven't seen it before, uh-oh. Dun, dun, dun. So you've got a little Mario here, and he can hop around. Now the interesting thing is that you can pause and go back in time. And then you can change your program, and like different things happen. And you can also track what's going on. So this was a guy named Laszlo Pandy who was just interested in debugging. How can we do this in a really cool way? And he decided to like go and give it a try. And when I first saw the demo, like I didn't really understand what he'd been talking about. And then he showed me the thing, and I was like, oh, okay, this is a big deal. This is cool. And so this culture of just like go out there and make something useful, I think has been really valuable in that way. One final piece is a style guide. So a lot of people will say like, oh, those ML languages are hard to read. And what they're saying, in fact, is those people who use ML languages write code that's hard to read. So it's not quite the same thing. It's not an inherent fact about an ML language, or it's that there's a coding style that isn't super professional that's very, very common. So as a quick example of this, we have two different ways. So the top is what I recommend. And we took a lot of lessons from Python here, actually. So you can do certain layout things. So in this one, we always have 2 spaces between top-level definitions. This is something that Python does. It lets you chunk functions in a much easier way. We also say, always bring things down on a new line so that you can sort of visually see things in a nicer way. And the goal here is like, how can we have code that is going to last for 5 years or 10 years, that when you go do a blame on some change, you're going to actually point to something real. And a lot of code that I've seen on the internet in some languages looks more like this. Like, it's much more compact. It's easier to fit on a slide for a presentation, and it's easier to fit in the 2 columns of an academic paper. But it has problems, right? So if I ever need to add another case that's longer, do I move all of these? Do I leave them? If this case becomes really long, I have to move it down, but do I move all of them down? I'm just creating a maintenance problem for myself that didn't need to exist. And so part of what I want to make a value of Elm is we're writing code for like real use in the world, and so we need to have a professional style. The last point is I have a guide for designing packages, which is just a set of best practices. But essentially, how can we help people make really great stuff? Okay, so finally, we'll get to a more technical aspect of this. So usage-driven design. So what that means to me is start with the minimum viable solution, something that will work, and maybe it's not enough, but maybe it will be, we don't know. And from there, see if there are any concrete issues in practice. If so, bring that information back in and either update your solution, make it a little bit more powerful. What's been interesting is that the minimal viable solution is often enough. So we have a couple of examples of this where we've gotten very nice results from keeping things simple. So one example of this is static signal. So if you're not super familiar with Elm, I don't know if this will make a ton of sense, but essentially values flow through your program in a particular way, and in Elm you can't reconfigure that flow. And so folks who had been working on FRP were very, very skeptical. They were like, how can you make a interactive list, a dynamic list where there are stateful elements? And so like, how could you make a list of counters where you can add and remove counters? Something like this. This is also in the time-traveling debugger, so you can go back. But so how can we do something like that? And so I essentially made the wager of we could add something complicated, or we could see if this actually can be solved with the minimal solution. And so what ended up happening is this turned into the Elm architecture. So there's a nice pattern that you can use to structure your Elm programs that gives you modularity, gives you testability. It's very easy to stamp out. And we're starting to see it being sort of ported over to ClojureScript and React code. Perhaps sometimes that's co-invention. Sometimes it's people saying, hey, I saw this cool thing, let's do it here. But what that means is we're able to start with a very simple setup. So this is similar to the counter that I was showing before. I have a model, which is an integer. I have a way to increment it and decrement it, and I have a way to view it. Now I've wrapped this up in a module, so I can reuse it as many times as I want. So when I create a list of counters, I just import counter, and then I use those functions. So I can initialize it, I can update it, and I can view it. And all of this is just reusing that code that I wrote before. So now when I add features to counter, this code doesn't need to know what's happening there. I just have a way to update it and view it. So you get this very nice modularity. And I don't think we would have ended up with that solution had we started with what was the more complex thing that sort of was the generally agreed upon way of doing things. Another example of this that's, I already regret putting this in here. So at this moment, Elm doesn't have type classes. So this is something that's controversial for some people. So for JavaScript programmers, this is a feature. People love this. For Haskell programmers, this is a travesty. This is terrible. I can't believe it. How's it even possible? So part of this is that a language exists over 20 or 30 years. And when you release a feature is also part of the feature, right? So if you add a feature in the first year, the whole culture that grows around it is going to use that. If you add it in the 15th year, that whole community that you built will have a way of doing things, and you introduce an advanced feature for advanced users. So you can totally change that usage in practice by thinking about timing. So one interesting result that's come from this so far is how we do our JSON parsing. This was something that we weren't really sure how it was going to look, but oops. So this is how we represent our documentation on the documentation website. So I have documentation has name, comment, and then all the values and such. And the way we get that out of JSON is with this decoder. So I say, hey, there's a name field, it's a string. There's a comment field, it has a string. there's a bunch of values, and that's a list of, let's actually look at it. There's aliases, and that's a list of alias. So let's look at what alias is. That's also a decoder, and it has certain fields. They have certain values. So you're able to sort of build up these JSON decoders in a really nice, explicit way. And that's not tied to any particular type. I can make 5 of these for documents. Maybe they're different eras of documents, like I changed the format at some point and I need to have a decoder for both of those. It makes that really simple. And you might say, okay, well, I'd rather not write this code. So that doesn't actually need type classes. This is something that you could perhaps generate based on the type declaration. So you find yourself in a situation where you actually end up with a pretty simple solution that you wouldn't have seen if you had a fancier tool in your toolkit. So the overall observation here is that simpler foundation produces simpler code in practice. And that, I think, is a really valuable thing. And if you're going to give away simplicity, you better be doing it for a very good reason. That doesn't mean that you can't, but you should at least know what the trade-off is that you're making. So the final thing is tooling. So because we have sort of all these invariants about typed functional language, so Elm, for example, is immutable. We have managed effects, so effects aren't just happening arbitrarily. We can use that to create unique and delightful experiences, stuff that couldn't be created by some other project. So Elm is competing with languages like Dart or TypeScript, where they have a team of 20 or 50 people. And I can't compete, like, even if someone's 10x, that's 20 and 50x. No one even talks about that. So the way that you can be competitive is to design things that just can't be done in those languages at all. So one example of that is the time travel debugger, which we saw. Another example is automatic semantic versioning enforcement. So this is something that I don't know if a lot of people know about. So let's say a new version of Elm HTML comes out, and it's a major change, and you want to know what happened. So we can run diff, and it'll say, hey, these 2 things were added, and we changed call span to take an int and row span to take an int. So what happened here is someone read the spec more carefully than me and realized that in those particular cases, you can't give 4 pixels or 4%. You really have to give a number. So you can actually look what exactly changed. And so this can be produced at any point. So when someone's going to release a package, we run this and say, hey, it looks like you added, removed, such and such. And we can say exactly, this is a major change, this is a minor change, this is a patch change. And that means every package that is released follows these rules. And maybe that's feasible in some languages, but if we're competing with JavaScript, this is a really nice thing. And there are a lot of fairly well-known cases in JavaScript where a big project will do a patch release or a minor release that breaks a lot of stuff. And they say, well, it wasn't really that big a deal, so I didn't. But you violated everyone's constraints, and their builds are broken, and they can't push to production. So this rules that kind of case out. Another thing that we did recently is friendly error messages. So sometimes people say, I don't like using these type languages. Those error messages are a pain. And the realization here is, like, maybe they are painful. Maybe we can make them better in certain ways. So the way this ended up looking is we tried to think about what would help the user the most. So on the left, we have a little code snippet. And on the right, we have the error that is happening there. And so we get the little red underline. List doesn't expose nap. Maybe you want one of these other things. So it's very explicit about what's going wrong there. Another example of this is, oh yeah, this one's great. The first argument to the function has an unexpected type. It looks like the record is missing the field age. If you look at the program, we're giving Herman is over 50 and trying to get his age, but he doesn't have an age. So we've directly identified in a way that a person can read what's going on in that program. Yeah, so essentially by focusing on sort of the user experience of these error messages, we can get a better result. And so the hope here is, this is a work in progress, and the hope is that we can get to a point where these error messages actually start to feel good. We can get to a point where it's just helpful. I'm writing a program and it says, hey, check out this line. This particular thing is going wrong here. And I think it's conceivable to change the relationship people have with a compiler from adversary to assistant, right? So instead of the relationship being like, hey, check out this code, no. What if I mess with this? No. How about this other thing? No. Okay, this? Yep. And then maybe it crashes anyway if you're using Java and you have a null pointer exception. To something that's more like, hey, here's this program. You should change this and avoid a crash that way. So I think that's a long-term process, but I think we should think about trying to move in that direction. Another thing is the startup experience of using Elm. So I want people to like accidentally learn Elm if they come to the website. So I have all these examples. And so like the hope is that you can click on one and say, I'm interested in that. And just see how that code's working directly. And one nice thing here is that we have little hints so you can go read about what's going on there. So if you want to know what a div is, you can go look at that. I think that will start to turn into more advanced editors and IDEs and such, but having that experience really helps people get started in a quick way. This one will be interesting. So based on the design of Elm, we can be faster than JavaScript, like from a theoretical foundation. So this is a really huge engineering project, but this is something that if we're able to achieve, this is a huge benefit. One thing JavaScript programmers really love is performance. So when ASM.js came out, people were like, when are you going to be compiling to that? It's like, you need a garbage collector. And then when WebAssembly comes out, they're like, oh, okay, how about, yeah, can you use that? And it's like, oh, you need a garbage collector. So I suspect we'll eventually have one, and we'll be able to actually deliver on that. But the message here is that like invariants are Elm's competitive advantage. If we can provide experiences that you can't get anywhere else, that people haven't seen before, that are delightful for people, then I think we have a much better chance of being the next sort of chunk of programming history. So that's sort of the outline of user-focused design in Elm. And hopefully that's going to help us be mainstream. Thanks. Any questions?
Something that people really like about using JavaScript for building their client applications is that they can use JavaScript on the client and the server and then get like these server-side rendered applications using the same logic. Is having Elm run on the server a thing that
I think it's likely to happen in the next release. So essentially I wanted to focus on a clear niche before expanding out too far. Like I felt if you have a really broad focus, you're going to do a lot of things poorly. But we're at a point now where I think we can start running on Node. And the long-term hope would be to just be running, compiling to assembly and running much, much faster than that and having different sort of, having better support for concurrency and parallelism and such. But that's coming.
So there are different theories about what programming language adoption follows. Some people think that it's based on killer apps. Some people think it's based on features. What if it is really entirely random? I would say that observationally it does seem to be kind of random.
If that's the case, it's not going to hurt to operate under a different theory, right? So trying real hard to think through what it might be, and if it does end up being random, this won't hurt. But another part of this is that there's sort of different trajectories for languages that have been successful. So you have the sort of big, like, languages from corporations, and for a long time that was the only way you would have the resources to make a language, so like C and Java and such. But you also have sort of languages that got started out of like some person working on it. So Ruby and Python are sort of examples of that. So I try to, Scala and Clojure as well. So I try to look at those to see what techniques might have been influential in making that happen. But maybe it's random, in which case, like, that's, yeah.
How do you evaluate the guidelines you described, say, whether you make these choices, say, introduce a new concept or try to reuse the existing concepts and so on, whether it is helpful or, say, gradual learning. Does this work only in San Francisco, or would it work also in the communities elsewhere? So how do you know whether the choice you made was the right one?
So I feel like San Francisco is actually a more, it's a tougher city for typed functional programming. I think it's true. On the East Coast, you have a lot of it. And part of that's because of the universities that, like, what the professors' particular loyalties are to. So on the East Coast of the United States, you get a lot of typed functional stuff. In Europe, you get a lot. On the West Coast, not really as much. So I try to just ask people very aggressively how things are going and, like, what their background is and such. But it's hard to, I would be surprised if there was an advantage in San Francisco. That's a place where the thought experiment about having 6 different pitches, in San Francisco it's like you have 80 different pitches and they all have a meetup tonight. And you have to, like, and you're just like, I don't know. So San Francisco is tough.
When's Elm going to have macros? Just kidding. Do you have any data on or some examples of the complexity of applications that are being built in Elm right now? Like, what's the largest one like?
So that's probably the folks at No Red Ink. So the particular part that they did in Elm, so it's helping people learn grammar. So the example that they show is they're helping people learn passive voice and active voice. And apparently people answer 2.5 million questions a day on that chunk of code. I don't know how huge that code base is, but it's not like we've got like JavaScript scale tens of thousands, hundreds of thousands of line projects yet.
Yeah, so a lot of the things that you mentioned seem to make a lot of sense, especially in the context of Elm. But they also, the trade-offs with a lot of the decisions that you've made that, as I said, makes sense in the context of Elm, but you also seem to be sort of suggesting to the general functional programming community. And I'm wondering whether, and some of those lessons I think we really should learn, but I'm wondering whether it isn't, so for instance, losing the connection in our terminology with academia seems like it's a trade-off, or not having type classes. And I'm wondering whether instead of making those trade-offs, we can't just have you be the sort of, Elm be the gateway drug, and so you do all those things and say, oh, go try out all the other functional programming languages afterwards.
So
and whether that's, yeah.
I think that's plausible. The point I want to make here isn't that all ML family languages need to be making these decisions, but starting from, like, who is your user exactly? How can I cater to them in particular? How can I set up my messaging so people know what they're getting themselves into? So my experience has been, in some communities, there's disagreement about, like, is this a research tool? Is this a way to make products? Is this, and so that can be quite confusing. But the answer may be the actual user of that language is defined in a different way, and for that user, you need to think about different things. So I wouldn't say, like, oh, do all this stuff in Haskell. Like, I don't think that's a good idea. Does that kind of, yeah.
What is the production usage of Elm right now? Are there any, like, real-world large applications built with it?
So I know of 3 companies definitely that are using it. So one is this company in San Francisco. One is called Circuit Hub, and they're doing some diagram rendering with it. And there's a German company who's using it for some internal tools, but we haven't gotten a massive app written in it yet in production.
So you're working at Prezi. They're not using Elm in production? Are they
So-
going to?
They are going to. It's a more complicated story than maybe I want to share.
Okay.
But essentially, we're in the process of doing a rewrite from Flash to JavaScript, and when you're doing a big rewrite, lots of things are complicated besides like the languages involved. So there's lots of factors there, and I think it's going to be some more months, but I think it's going to happen.
Any other questions?
Phil has a question. It's kind of an honor.
One of the big factors in language adoption and learning is familiarity. Right? It's not just that it's easier to learn because of the context. People know. So what choices did you make in the design of Elm to make it familiar, like something else? Right? That's to a large extent why Java and JavaScript succeeded, because they looked like the thing that came before them.
So I can give one example and one counterexample. So one example of trying to make things look familiar is we have a concept of tasks, which looks very much like promises in JavaScript. And so you sort of have this one-to-one mapping where, hey, you know promises? We've got tasks. The API is quite similar. And that's filling the role of the I/O monad without introducing that sort of conceptual world. So an example where I think I don't really know what the answer is, but so I went with syntax highly inspired by Haskell and OCaml. And for a lot of people, they're like, this is crazy. And it's not clear to me what the right solution is there, because if I look 5 years down, it's the right choice how it is. If I look at today, maybe there's some benefit to making things a little bit more familiar looking. So I'll share an interesting experience on that. So I've had people come up to me after talk and say, hey, that syntax looks a lot like Python. Was that an influence? And I was like, no, but I'm so happy that you think that. So I think the style guide that we set up for Elm is going to help a lot with the perception of craziness. So for people who are coming from stuff like CoffeeScript, it's not that wild in terms of syntax. So I'm making a bet that we can get away with certain things, especially if the overall message is it's really important to make things easy to learn. At least perceive how we got to Java. And when JavaScript looks at Java, they're like, how did people deal with all those freaking types? Like, how can you get anything done at all? And so I have a feeling that we're at another one of these crisis points where the issue again is maintainability. So when you talk to companies that have, let's say, 50,000 or 100,000 lines of JavaScript, they're in this place where when they add a new feature, they're going to break 3. So one way I think of it is Facebook used to say move fast and break things. And I think it's sort of shifted to move slow and break things. So what I'm getting at though is at a large enough scale, people are starting to see issues in practice. And that's not to say that this isn't a valuable place to be, but we're starting to get these rough spots. So the question you might ask then is well, okay, so what's this next era gonna be? What's the next part of this history? And so maybe that's something functional. Maybe it's way crazier than we imagine, and it's a stack-based language or a Prolog, right? Something insane happens. Maybe types won't be involved, maybe not. So a Lisp or an ML Maybe it'll be something gradually typed. These are all viable in different degrees, right? I add this Prolog and Stackbase because, these are small communities that people really love a lot, and maybe they're great, right? Like, they say they're great. Should I believe them? I don't know. So for me, I think of, well, a typed functional language is going to address a lot of these issues. We can look back at history and say, we got the memory management under control. We got all those freaking types under control in the sense that if you can infer all that information, you can get a lot of the benefits without the really heavy syntax that a lot of JavaScript programmers look at and they're like, ah. So, and then maintainability as well. So the problem with that is that in 1973, ML was introduced. Okay, so this is 1 year after C. C was 1972. But first, I'm like, okay, that's not exactly how history went. Okay, but this is as seen from JavaScript. So C comes along, and suddenly we're not doing this really low-level thing. We're doing a much higher level thing. And that's true for many, many years. And at a certain point, we get to this other crisis point where it's like, and Java comes along, and we're like, oh, great, this is amazing. Eventually, we get into JavaScript. And these are sort of roughly arranged time-wise. It doesn't exactly line up time-wise, but from the perspective of JavaScript, you sort of say well, before us there was Java, and before them there was C. And it's kind of true enough. In fact, it's true from that perspective, so it might as well be true. So when we look back, the C and Java and JavaScript programmers can all look at assembly and be like, oh, it was a maintainability nightmare. I couldn't write this in a portable way. I couldn't have people read this easily. So we solved that when we went to C. And now the Java and JavaScript programs look back at C and they're like, memory management. How could they even deal with that in that crazy language back in the day? And so that sort of was the ingredients of this crisis point is that we're engaged in a decent amount of self-destructive behavior. So I kind of want to talk about sort of how Elm how I think about these things and how Elm tries to do a better job dealing with those things. And I don't want to be like a mean guy. So I tried to frame things in a positive way and not be too mean or anything. This is all meant as a how can we do better kind of thing. So for me, I think it's valuable to sort of think about the history of programming in trying to figure out what's going to come next. So this one's actually the history of programming as seen from JavaScript. So if you try to do I tried to do a more realistic history. It just broke down. So what does history look like from JavaScript world? So in the beginning there was assembly, and it was hard, but somehow people wrote Super Mario in it. So that was pretty cool. But we got to this crisis point where things just weren't working out anymore. So along came C, and now we have the structured programming approach. Hi, so I'm Evan Triplicki, and depending on where you're from, you might say it different. So I designed this programming language called Elm that's focused on front-end programming, so doing stuff in the browser, interactive applications, games, this kind of thing. And so I'm sort of coming from a perspective of typed functional programming. And one thing I think about a lot is this question, if typed functional programming is so great, how come nobody uses it? And I think this is a question that people sort of outside this community ask, and I think it's a reasonable question for them, just as a filter, right? Obscure things aren't always amazing. It's something that I don't think we ask within that community enough, right? Why is it that we don't have more users, if it is true that we really are doing something really great? So the rough theory